some people that are on their phones right now. Not the other phones, they'd be doing better in this class. Crazy. It's amazing how that kind of works. Okay, let's see. You should be seeing something interesting happening with both of these. So the y gets its turn, right? FOIL wouldn't do worse shit here, right? So y times y squared. Y times negative 3y.
Minus y squared, 4y squared.
Y times 9. And then the 3 gets its turn. 3 times y squared is 3y squared. 3 times negative 3y is minus 9y. 3 times 9 is, I just kind of lined up my like terms. You don't have to. Those die. Those die. And over the y cubed plus 27. Some of you guys might know this is called, remarkably enough, we call this a sum of cubes.
Oh yeah,
This is a sum. And y cubed is y cubed. And 27 is 3 cubed. So this is a sum of cubes. It's going to become important when we go to factoring. Notice how there's a little dude and a big dude. That's the way I teach it when I teach how to factor it. Right now we're just multiplying, so enjoy this. Factoring is going to be more difficult because you got to work backwards. Yeah.
Isn't foiling just distributing them?
Foiling stands for first, outer, inner, last, which only works for binomials. So I'm sure you guys just really don't get my point, but we didn't need to invent that. It's just extra crap we didn't need. And the more extra crap we don't need on top of math, the more it makes it seem like, oh, it's all, you got to memorize everything. No, just distribute. I don't care how big it gets. All right, maybe. I don't know if you guys see what I'm saying. The more little songs, the more little mnemonic devices, the more it seems like, oh, math is all memorization. Oh, that's why they had to invent all these FOIL and all this shit. No. Okay. Number 3, the same kind of thing should happen. So you get x cubed plus x squared plus x, and then minus 1 gets a turn. Minus x squared minus x minus 1. And what do you think us creative geniuses call this? Us creative geniuses being us mathematicians. The difference of cubes. Because what's 1? 1 cubed. X cubed is x cubed. See again? 1 cubed is 1 times 1 times 1 is 1. And 1 is 1 to any power. Because it keeps on being 1. Alright. Did you guys have to realize anything right now? Not really. I just want to show you this couple. Did you have to know going in that stuff was going to cancel? No. It just happened to happen. You guys understand what I'm saying?
Yeah.
So the whole section about special products, it's kind of nice. I will reference it a little bit, but it's really not that important to know ahead of time how it's going to come out. You just attack it. You just repeated distribution. All right, maybe. Okay, I like it. Let's see. Ooh, here's some more recent stuff. We're going to do number 4 and 5 real quick. This is page 124. 1, 2, 4. What did I say? 4 and 5. 4 et 5. 4 et 5. Français. Je parle un peu de français. Took 3 years of French, and all I can say is I go to the beach. Je vais à la plage. And the wastebasket is La Corbeille. It always sounds like a 70s big-ass car, La Corbeille.
That sounds really fancy.
Ricardo Montalban is here to tell you about La Corbeille. The wastebasket.
It's
Such a beautiful image.
You know anything in Russian?
from yet.
Oh, nice.
Thank you. That's about it. And of course, everybody knows yet. Kasha and sign language. So really the only reason that expressions with multiple variables, x, y, z, a, b, c, whatever, has its own section is because the degree is a little bit weirder to get. It's not just the power, you gotta add up all the powers in every term of all the variables. This is the same as always. There's one little place that confuses people sometimes. Let's see if you guys, I think all you guys should be okay with it. When you start doing number 4 there, you get 12x squared plus 3xy. And I always get somebody to do this, which is fine. You can see y, ayx. And then what's negative 2y times y? Negative 2y squared. And then they just don't realize that these two in the middle are actually like terms, so they're just out of order. Y times x is the same thing as x times y. So you get 12x squared minus 5xy minus 2y squared. It's just convention to put them in alphabetical order. How are we doing? You guys okay with this? I mean, this is something you could just sink your teeth into. This is like, oh, thank God. No matter what's in there, you do the same thing. Yeah, let's do this one, and then I'll give you one that's a little bit harder. What's the thing about this guy? What do you have to do first?
Write that twice.
Yeah. Don't be that silly person that says it's p squared plus 9q squared. No, it ain't. Right? It's the same mistake people make when I say like 5 plus 2 squared, and they say that's 25 plus 4. 29. No, it ain't. 5 plus 2 is 7 squared is, way is this shit, right? So squares cannot play nice with addition. They don't distribute across addition because they're not based on addition. I know I've said that many times, but it's normally the 10th or 12th time I say it that it sinks in to some people's heads. Okay. Now this one, I just do this like normal, right? P squared, 3pq, 3pq, 9q squared. I like it. I like it. And then you get p squared plus 6pq, 9q squared. I feel like q's look better than mine, but 4 little q's. All right. I like it. I like it. Okay. Ooh, yeah, I like it. Let's do this. Ha, ha. Sorry. I'll stop. Next page, number 7. Do those 4 problems there. And then on the bottom of this page, I'll give you more interesting problems. You guys can't check your answers with each other, that's fine. Part C and Part D are going to be a few more steps to it. Let me look at the first two real quick. I have a feeling that most of you guys are probably in the middle of the last two. Sometimes I got to keep this function notation idea alive because it is very useful. It's used all over the damn place. So you cannot forget how function notation works. It's just substitution. A few of us still have some trouble with it. But if P of X is this business, P of 2, which is what the first one's asking for, just tells me to make X 2. So I replace all the X's with 2. So this would be 2 squared plus 2 times 2. Yeah, then plus minus 5. This is 4 plus 4 is 8, minus 5 is 3. Cool. That's all it is. It's just substitution. Function notation. So what is this telling you to put in place of x? A. So instead of x squared plus 2x minus 5, this is A.
3.
3, what's that? Yeah, put an A in place of x, and you get A squared plus twice A minus 5. That's it. If P of x is x squared plus 2x minus 5, P of 2 is 2 squared plus twice 2 minus 5, P of A is A squared plus twice A minus 5.
You're supposed to plug in the 3 from A to...
Oh no, hell no.
That's what I did.
This does not say A equals P of 2. This says part A is P of 2. I like it. So how do you do this one?
Same thing. Plug it in.
Use all of it from here. So P of x is x squared plus 2x minus 5. P of A plus 2. You've taken A plus 2. And you put it wherever you see an x. That's all it is. That's it. It's the most single-minded thing. You replace x with whatever the hell's in there. So I'm going to have A plus 2 squared, because I'm going to throw that in there, plus twice A plus 2 minus 5. You guys, if you haven't done it yet, go ahead and simplify that a bit. Don't just leave it like this. There's a lot of stuff you could do there. I could do it, Jeff, but you know. Do so much for you, man. I don't do shit for me. I don't know if you guys realize. I don't do anything for me. So then here you get A squared plus 2A plus 2A is plus 4A plus 4.
Plus 2A plus 2.
Is that cool, guys? I went in and put the two like terms together in the middle. You get 2a plus 2a. And then you just finish it out. A squared plus 6a plus 8 minus 5. Booyah. Alright. I apologize for that. Booyah. So you guys do part D. You haven't done that yet, do part D.
What did you get for this? Second to last? So guys, again, guys, when you do the first step, you plug that thing in. What you've done for yourself is you created several little problems. One problem is a plus h squared.
Yes.
Not a big deal. You write it twice, FOIL it out, right? The second problem is distribute the 2. And the third problem is don't forget your minus 5. So it's the same format, something squared plus twice something minus 5. Something squared plus twice something minus 5. It's got to be that format. What is that something? Whatever the hell's in there. And then you just simplify whatever it is. So now here you're going to get a squared plus right, 2ah.
Plus h squared.
Is that decent? You get a squared for sure, right? You get a squared, just let me show you the step I've skipped. A squared for sure. A times a is a squared. A times h is ah. A times h is ah. H times h is a squared. And then these combine to make 2 ah's. Alright, let me see some questioning looks out there. Let's just focus on this for a second. A squared plus ah. Is that cool so far?
Yes.
Yeah.
Right? Because the a gets a turn to go through. Distribute. And the h gets a turn. H times a I can write as ah in this alphabetical order.
plus h squared. What's up?
Oh, I was just gonna say, so, I guess I was forgetting to distribute the h to the a again, so I just added h squared.
Oh, I see. Poor little dude.
Yeah.
So you've got to end up, before you put like terms together, whenever you do binomial times binomial, there'll always be 4 terms, and maybe a few of them are like terms, but there'll always be 4 terms to begin with. And then we just happen to be able to put the two in the middle together. That's where we get a squared plus 2ah plus h squared. Then you bring down the plus 2a plus 2h minus 5. Are there any like terms? No. There's no other a squares, no other ah's, no other h squares, no other a's, no other h's. Kind of makes sense that there won't be very many like terms because they had a and h and 5 to start with. They're already not like terms. Maybe. Would I know that ahead of time? Should I know that ahead of time? No. This is shit. You FOIL, you distribute, you get your any like terms together. There just happen to be no like terms on this step. Yay, right? Let that be nice. You didn't have to know that ahead of time. Okay. Yes.
Okay, so for the 2AH, why is it not AH squared? Or is that the same thing?
Definitely not the same thing. A 2 in front of something means 2 of those doing what? Adding. Right? So if you thought it was AH squared, they should have been doing what to each other? Multiplying. And they are not, they are adding. So when you add, coefficients change. When you multiply, exponents change. Okay. Alright, maybe I won't do that. I heard something. We'll just stick with this. Okay. I think again, the thing that gets most people down with a lot of math problems is you're just not you don't come in with the ability to separate it. You feel like you're supposed to look at the whole damn thing at once. Which let me tell you, there's not a lot of really good mathematicians that do that shit. Because they know, I got a human brain. The human brain can't do that. I've got to break it into parts. That problem is a semi-easy problem. It's just a foiling problem. This problem is just a distribution problem. And this one is just minus 5. So you got to break it into parts, where every part is easier to work with. Maybe. You guys are really bad at word problems for that reason, because you think you're supposed to be able to read the word problem and then set the equation immediately. I'm like, wow. If you get to the point, teach me. The student has become a master's. That's not the easiest thing in the world to do. Okay. All right, so what have we done so far? We figured out what the hell polynomials are. We added them, we subtracted them, and we multiplied them. So what's left to do? Divide them. Do a quick recall. How do you do this? You do not kill the 4's and make it a minus 8b. What's being divided by 4? 4a and 8b, right? So the best way to do this then, to make sure you don't make a silly mistake, is to say this is 4a over 4 minus 8b over 4. See how that's kind of like undoing subtraction of fractions? 4a over 4 minus 8b over 4 would equal 4a minus 8b over 4 because they have like denominators. So I can just tear them back apart. And now I can divide this. What do I get here?
4k to the power.
Yeah, I get a minus 2b. Or not. Okay, so how do you think I do Number 1 then.
Same way.
Same way. Yeah.
Split it up.
So try to do number 1. Yeah. Okay. Alright guys. Alright guys. Yeah, so guys, this is your first step, right? That says divide all this shit by 2k. So I go, okay, I'm going to divide each of those things by 2k. So yeah, you get 4k to the 4th. I like it.
2k squared
2k squared.
plus 2.
Oh, you got it. Plus 2K.
2k. I like it. Notice something. Guys, you're dividing by 2 and k, so all your numbers get down by a factor of 2, and you lose a k. So 8 goes to 4, you had 5, now you got 4. 4 goes to 2, you had 3 k's, now you got 2. So forth. I mean, that's another way to kind of look at that.
No, you don't subtract.
Say again?
You don't subtract.
Of course you do. What's 5 minus 1?
6K.
That's not.
Oh. Alright guys. Nothing you've ever learned in math can ever suddenly become different. If you ever think that's true, you need to come see me. 8 divided by 2 has always been 4 and will always continue to be 4. What is it that we subtract when we divide? We subtract powers. Yeah. In this first term, is there a 5 in this first term? Is there a 5 in this first term? No! Good. The less you feel insane when you say that, the better off in math you are. There is no 5 anywhere in this thing. There's an 8 and a 2, there's 5 k's, and a k. You guys see this? So 5 k's divided 1 k away, and of course you're left with 4
I was
k's.
doing it
So,
completely backwards.
I got you.
Subtracting and adding the power.
Shit.
Yeah.
So please let that make sense. When you're dividing, you're losing stuff. When you're multiplying, you're gaining stuff. What about number 2? Bless you. For some reason, people give me one-term answer, which makes no sense. I can't divide and get 0. It's impossible. Unless the top is, unless I already had 0, right? Yeah, what's this first guy? Well, how many x's you got left? 2. And 20 over 15, as it always has been, reduces to be?
4/3.
Yeah, you divide by 5, 4/3.
Minus 1.
Yeah, minus
Uno.
what? Or you can write this as 4x squared over 3 minus 1, same thing. You can have 4/3 as kind of like a coefficient.
Like, could you put the 1 next to the 4x?
It's a separate term, yes. You guys see that? Is that cool?
time. You feel like you're in a debate when you hear somebody's ding, ding. No.
Isn't this cool enough?
Oh, this is, the only thing about number 3 that's different, do you see how the first piece looks a lot like number 1 did?
Yeah.
And then the last piece is actually the nicest piece of the whole damn thing, which is funny. So here you would first break it up. Yeah. See this piece right there? No, you don't. This piece right here?
Yeah, it just stays.
It's done.
Yeah.
It's the nicest piece there is. So each piece, you just reduce the fraction of numbers, and then use powers, the properties of powers for the other piece. -8 divided by 2. How many k's you left with?
3.
3. 12 divided by 2. 6.
X squared.
K
Sorry.
squared.
Plus K.
1k left, I like it.
Minus 7.
Now here, 7 over 2 is
7.
7 over freaking 2, right? Don't make it 3.5. Leave it as a fraction.
Plus.
And the k's cancel, right? Plus 3 over 2k, because nothing here cancels. So let that be the nicest one. Yeah, nothing to do in the last one. So this is exactly like I was talking about. The whole problem, the whole thing at once is remarkably disgusting. But each little piece should be relatively easy now. So if you can break it up into parts and not give a shit about the other part when you're looking at a single part, you'll be much better at math. That's the key for a lot of math, is being able to break it up into parts. Tired of the rectangle problems. Good. Good. Alright, we're gonna end real early, but just to give you a little preview, you should review long division of numbers, because we're gonna long divide. Where's all this shit? What? Yeah, you should review how to do this. It'll make it a lot easier to be able to do this. Oh well. Alright. I'll see some of you guys in about 20 minutes or so. 15 minutes, I'll be there.